Okay. So we're going to try to record this and see what we can do and have some fun. All right. We're going to start out with a problem that's kind of been moved over a little bit. That's what this x pi minus 3. So first of all, we want to find the period of our function. So the period of the function is 2 pi over b. Now, b is the number in front of x. And in this case, b is 1. It's not the pi over 3. So it's 2 pi over 1. So our period is 2 pi. So our function goes from 0 to 2 pi. But what we're going to do is we're going to put our translation in here, our movement in here. So it's x minus pi over 3. This is equal to 2 pi. So we've got our kind of our domain set up here. It's from 0 to 2 pi. See, the period hasn't changed, so it's just 0 to 2 pi. All right, so to solve this thing, what we're going to do is we're going to kind of work from the inside out. We're going to get rid of this minus pi over 3. So we have to add that to each part. So we get pi over 3 is y center equal to, and I put in a positive so it would cancel out the negative. Those add up to 0, so it's x minus 0, or just x, is less than or equal to. So what's 2 pi plus pi over 3, huh? Well, let's change 2 pi to 6 pi over 3. See, we multiply the top by 3 and then the bottom by 3. It's 2 over 1. 3 times 2, 3 times 1, plus the pi over 3, 1 pi over 3. That gives me 7 pi over 3. So now we've got our divisions. It's going to go from pi over 3 to 7 pi over 3. It's like been scooted over. It's been moved over from where it should normally start. Normally it would start at 0, right? Now it's been moved over a pi over 3. So how do we go ahead and graph that? Let's see how we're going to do this. Where normally we have, what's our division? 0, pi over 2, pi, 3 pi over 4, 3 pi over 2, I should say, and then 2 pi. Okay, that's usually our split ups, right? And since this is a sine function, we normally go 0, 1, 0, negative 1, 0, right? So the sine of x is, when it's 0, the value is 0, then it's, should I have these kind of backwards? So when sine of x equals 0 degrees, it's 0. When it's pi over 2, it's 1, and so on. So now what we're going to do is we're going to change our interval, right, a little bit. So our new interval is going to be pi over 3. This will be the sine of x minus pi over 3. And it's going to go to 7 pi over 3. But we need the numbers in between here. Well, 1 plus 7 is 8. Half of 8 is 4. We could add those together. 1 and 7 is 8. So this would be 4 pi over 3. That's not too hard to get. We just kind of add those together and divide by 2. Is that correct? Yes. But then we need the numbers in between. So let's change this to 6's. Let's change this just kind of make a little notation. This would be 14 pi over 6. We're going to double this. This would be 8 pi over 6. And double this. This would be 2 pi over 6. So now we need a number in between there. 2 and 8 is 10. Half of 10 is 5. So this is going to be 5 pi over 6. So it looks like we're adding 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So this is 5 pi over 6 and 11 pi over 6.
I'm sorry.
Using this kind of as a guide to help us.
Mr. Mitchell,
Yes.
can you kind of explain how you got the 5 pi over 6?
I doubled all these. Well, how did I get the 5? I added 2 and 8 is 10. Half of 10 is 5. I need a number in between these two, right in the middle. And that's why I used the denominator of 6. You know, so the denominators are the same. So I just added the numerator and divided by 2. Does that help? Same thing here. You could add these together. What's 8 and 14? 22. Half of 22 is 11. 11 pi over 6. That's why I changed them all to 6s. Instead of 7/3, I changed it to 14/6, 8/6, 2 6s. So I could get the numbers in the middle. I don't know if that is.
Okay. Yeah, that works. Thank you so much.
It's a little confusing, I know. We'll be doing some more of these too, and it'll get worse. No, so now we're going to divide this up. So we wanted to split it up into our units. So one way we could do this, let's look at our numerator. Just looking at the numerators, it goes from 2 to 14, right? The numerator. So what if we took our divisions and we split it up like this into 14 units? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, using the numerator. Don't worry about the denominator, just the numerator, 14. So our beginning point was 2 pi over 6. So we want to go over 2 units. We just make a heavier mark there so you can see it first. And then we want to go 5 units, 1, 2, 3, 4, 5. Here's another division. Then 8 divisions, 5, 6, 7, 8, 11, 9, 10, 11, and then finally 14. So there's our 4 divisions. 1, 2, 3, 4. Okay, so we can label these. You could put 2 pi over 6, but we'll put pi over 3, 5 pi over 6, 8 pi over 6, or reduce it to 4 pi over 3, 11 pi over 6, and 14 pi over 6, which is 7 pi over 3. So that's how they're usually writing in the book. They won't write it. Now, what about the sine function? Let's look at these values. The sine is what? At 0, it's 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's -1. And finally, at 2 pi, it's 0. There's no number in front of the sine, so we're just going to go up 1 unit. Our center line is going to be 0. So starting at this point, we're going to be at 0, not at the origin, but over here. We're going to be at 0. Then we're going to go up to 1, back down to 0.
Mr. Mitchell, can you bring your paper up, please?
Oh, I'm sorry. I'm sorry. So we divided this into 14 spots. Yeah, I'm sorry about that. 0, 1, 0, -1, 0. And that's how we're going to trace it out. So it's quite a bit of work to get these things in translation. Now, normally the curve would have went here and 12, it would have ended right here, 12 pi Probably right in here someplace it would have normally ended. This would have been our normal cycle. So it's been moved over just a little bit. It's been translated from where it should have been. We moved it over. This is pi over 3. But it's kind of hard to show that. So we wanted to extend it out so you can see it a little bit. I know sometimes in the book they do it kind of, they don't do all this breakdown. So what I usually do is I'm going to take this number on top and multiply it by 2, and this number on the bottom and multiply it by 2. This is giving my divisions usually 14. Sometimes we have to improvise, but most of the time that'll work. You want to try another one of those? Let's try another one before we move on. Let's try this one. This is let's see what happens on this one. I haven't tried this problem, so we'll see what happens. Okay, so what was the first thing we tried to do? We tried to find out our period, and we noticed that the number, we always look at our x term, the number in front of x, there is nothing there, so we're going to use the period of 0 to 2 pi. It's just 2 pi divided by this number, which is 1, 2 pi. So that gives us the period. It's going to be from 0 to 2 pi. That's our normal period. But we're doing a translation, so we're going to put in this parentheses in there. Normally, we would just put a 0 is less than or equal to x is less than or equal to 2 pi. But we have a translation. So what do you think we should do with the 3 pi over 4? Forget about it. No, we can't. So because we're going to be working with fourths, let's change this to fourths. How do we do that? We're going to multiply the top and the bottom number by 4. So let's change this instead of 8 pi, 2 pi, let's change it to 8 pi over 4. So it'll be a little bit easier to work with the fractions. Now I'm going to subtract 3 pi over 4. I'm not going to write the x down yet. And I'm going to subtract it here. So what I'm doing, I'm actually showing you the work. So this will be negative 3 pi over 4. These will become a 0. And this will become 5 pi over 4. So that's my range of my graph. See, the center line is still going to be 0, and we're going to go up 1 unit. Okay, so the next thing we want is our divisions, So what I'm going to do, I can do this maybe down here. I'm going to change these to 8ths. So I'm going to double this. This is negative 6 pi over 8. And I'm going to double this. And that would be 10 pi over 8. Right? So let's see. I should have maybe not put this in yet. Let's move it over here. So I need 10 units in this direction. And I need 6 units here. So I'm going to kind of spread this graph out. Okay. So I need a halfway point between these. How am I going to find my halfway point? I'm going to add a negative 6 plus 10. What's a negative 6 plus 10? That would be 4. And then I'm going to split that in half. So negative 6 plus 10 divided by 2. That'll be 4 divided by 2 is 2. The midway point is 2 pi over 8. Let's see if it looks like it would work. I'm going to make a mark here, and count off 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You see it's halfway in between. Okay, so I've got my midpoint right in there. Now I want to find the midpoint. Probably easier to find it between these two numbers. 2 and 12 is 2 and 10 is 12. Split that in half. That'll be 6. 6 pi over 8. Starting at the 0 point. This is my 0 point here. 1, 2, 3, 4, 5, 6. Does that look like it's halfway between these two? Yes. Now, you could kind of estimate where this is going to be right here. -6 and 2 is -4. Divided by 2 is -2. So this should be -2 pi over 8. 1, 2, wait, -2 right here. 1, 2, -2. Right there, we'll make a little mark. Now, let's convert these back to fourths because it might look a little prettier. On this one, I could have maybe stayed with the fourths. I didn't know. So it might have been easier. So this point right here, our beginning point right over here, is going to be -3 pi over 4, right? Dividing both of these by 2. Going to divide both of these by 2. This will be -1 pi over 4. I could have probably stayed with fourths, and I kind of jumped the gun. This would be positive pi over 4. Divide by 2, 3 pi over 4. And finally, divide by 2, 5 pi over 4. You see, so that meets our criteria. It goes from -3 pi over 4 to 5 pi over 4. I could have divided up into fourths instead of eighths on this one, but sometimes you don't know. Okay, so now the height is going to be 1. Let's draw a little line here. What kind of function was this? This was a sine function. So we know at the sine it should be what? 0, 1, 0, -1, 0. And we aren't changing that, are we? So it's going to start out here at 0. It's going to go up here to 1 at this point. It's going to go back down to 0. It's going to go to -1. And it's going to go to 0. And now we can graph it. Kind of spread out. It's kind of big. Well, that way you can see it all instead of all bunched together. Yeah, I could have easily had done these with fourths. You know, I doubled them because I thought, you know, sometimes you get like an eighth instead of a, this one came out nice, you know, it came out fourth. And sometimes you don't know. So we could have done this in just one, you know, instead of these other divisions, split up into 4 parts. But because it has negatives, you have to be kind of careful. Now, if you want to extend this, you wanted to go 2 periods, you would just continue doing it. Maybe go halfway here and halfway here, and you don't have to do so much work. All right. So let's do a hard one. Okay, I know what you're saying. No, Mr. Mitchell. No. Okay, we're going to do this problem right here. This is a cosine function. There's a couple of different ways you can do it. Okay, I'm going to show you the way I do it. Yeah, I had this this before, but I'm not sure. Show you correctly. Okay, so copy this one down. Are you ready? Okay, so first of all, we want to find, we can do our period of this function. And so what I'm going to do, the actual period is going to be 2 pi divided by this number in front of x, which is 3. Our period is going to be really 2 pi over 3, but I'm not going to do it that way. I'm going to set it up like this, that it's going to be 0 is less than or equal to 3x plus pi to 2 pi. We're going to leave it as 0 to 2 pi. When we have something like this in between, it's easier to do it that way. Okay? So, I don't have this. I was looking for this particular problem, but I don't seem to find it. We'll just do it this way then. Okay, so what we're going to do is we're going to, first of all, subtract pi. We want to get rid of this number that we're adding. So we're going to subtract or add a negative pi to all the sides. We don't really need that there. Let's see what we get. We get negative pi is less than or equal to 3x is less than or equal to 2 take away 1 would be 1 pi. Then we're going to divide everything by 3. So this gives me negative pi over 3 is less than or equal to x is less than or equal to I copy this one right? Oh, I'm doing this one in the book. I'm sorry, I'm doing example 2. I was looking at example 3. Let me get my head going here. Yeah, this would be I want to make sure I don't show you something wrong. Pi over 3. That's right. Subtract the pi from everything. We got 3 pi, got pi over 3, we got it, okay. So this is our final interval. So we could divide this up into thirds, but the problem with that is, we're going to have some numbers in between that might be a little hard to find. So let me draw my graph here. These will be our endpoints. But rather than using thirds, because that might be a little bit hard, it'd be easy to find these 3 points, but the point in between might be a little hard. I'm going to divide this up into 6s, okay? So I'm just going to jot it down here. This will be negative 2 pi over 6, less than or equal to, just to put a 0 here in the middle, halfway point, 2 pi over 6. So you can see this point right here, between here and here, would be 1 pi over 6. And over here. So this is going to be pi over 3, 0, negative pi over 3, and then the halfway point between these two is going to be our pi over 6, negative pi over 6, and positive pi over 6. It's going to be the number halfway between these. You could also do it this way. Take pi over 3, because our endpoint here was 0, just multiply it by 2, pi over 6. So that's how I find these two numbers here. This would be negative pi over 6. 0 plus 2 is 2, divided by 2 is 1. See? So we want always 4 divisions, 1, 2, 3, 4, 4 spaces. Okay, now what about the cosine? What about this -2? Normally the cosine goes what? 1, 0, -1, 0, 1. But now we're going to multiply everything by -2. So this is going to be -2, 0, +2, 0, -2. And that's going to be our points. So we're going to go up 2 units here and down 2 units here. And our graph is going to be at -2, then comes up to 0, then goes up to 2, then back to 0, then down to -2. Kind of our bell-shaped curve, like that. Pretty confusing, huh? Well, I'm trying to do my best to make it confusing. All right, let's try this next one. And if you need to look at this, I have recorded this, so you can see more misery. Here's our next problem. What the heck? Wait a minute, look at this. What's all this junk? Crazy. Crazy like a fox. Okay, notice that this doesn't have a translation. You only have a translation if you have a parentheses and something inside there. So this is not translated, but it does have this weird junk here, which we'll talk about in a second. So this 3 is going to help us find the period. The period is normally 0 to 2 pi, but we're going to take 2 pi and divide it by 3, and that's 2 pi over 3. So that's going to be our period. This is 2 pi over b. And b is this number. So let me put it right here. This one's nice because it is going to start at 0. There's no translation, and it's going to go to 2 pi over 3. Okay, we can see that maybe I'm making it more confusing than it needs to be. We can see this number. What is this number in between these two? This would be pi over 3. Now, the problem is trying to find these 2 points right there. You see, and it's a little bit harder. So if we change these to 6's, we put this as 2 pi over 6. And we change this to 4 pi over 6. Then if we add those together, 2 plus 4 is 6, and half of 6 is 3. We can see this is 3 pi over 6, or pi over 2. And this is going to be 1 pi over 6. So this is 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, 4 pi over 6. So these are reduced form. That gives us our points. Now, let's look at what this means. This is our 0 line, right? But this is saying that the center line is now going to be raised up to 3. So we're going to go up here, draw a line down here, 3 units, and this is going to be our new center line. Now, in some books, they put this at the end, which gets kind of confusing. So it doesn't always have to be the first number. Sometimes it's back here, which they might have 3x plus 3, but you want to make sure there's no parentheses. But anyhow, that's going to be our center line instead of 0. And now this number means we're going to go up to, let's make a dashed line there, and then down to. So our graph is kind of floating in space. It's going to be floating up here. It's been raised up. So the 3 becomes our new center line. And then we count up 2 units and down 2 units. So this is actually going through the number 5, and this is going through the number 1. Okay. Now, what about cosine? What's the, we haven't really changed anything to our cosine function. So yeah, we have. We used a -2, huh? So normally this would be, I'll write it down here. Normally this would be 1, 0, -1, 0, 1. That's normally the cosine. But we're going to multiply all these by -2. So this is going to be -2, 0, -2 times 1 is 2, 0, -2. So we're going to start at -2, going to go to 0. We're going to go up. We're actually not starting at -2. We're going 2 down from the center line. Then we're going up 0 units. Then we're going up 2 units from the center line. Then we're going back down to our center line. And then we're going down 2 units from that. So our graph is going to look something like this. I don't know what that points to in there. I think that was supposed to be a 0. Our 0 line. Okay, questions? Not the best drawings either. Probably more. Okay, do you understand how I got these numbers? This is 0, this is the number in the middle, this is the other number, but I had to find these 2 numbers, so I put them over 6s to do that calculation. Okay. All right. One last one. We're going to put it all together. This is the ultimate challenge. You're so quiet. I don't know if you're watching this or not. It said do it over 2 periods, but we're just going to do it 1 period. But I'm going to do it a little differently from the book. The book, to me, it's a little confusing the way they do it. They factor out the 4, and then they have to change this to a 1/4, and it gets a little confusing. We're not worried about these numbers right here. That gives us our center line. Center line is going to be at -1, and this tells us how much we're going to go up and down from the center line. This has to do with your amplitude. This is your amplitude right here. This is your center line. We call it CL right here. Okay, so we're not concerned with that. We're concerned with this parentheses. So normally this graph would go 0 is less than or equal to 4x plus pi is less than or equal to 2 pi. I think it's easier to do it this way than the way the book shows you, factoring out a 4 and all that. So we're going to get rid of the pi first. We're going to subtract pi, subtract pi, subtract pi. I'm getting hungry doing this problem. Negative pi is less than or equal to 4x is less than or equal to 2. Pi. Because I'm taking away 1 pi. I almost thought about canceling out the pi's. This should be 1 pi. 1 pi. There we go. Pi. Okay, then we're going to divide everything by 4. 4, 4, 4. So our range or domain of this function is from negative pi over 4 to x to pi over 4. Okay. So I'll make it a little bit easier to draw the graph, okay, on this one. Maybe this would help you. Okay, first of all, let's set up our grid here. I'm going to put the mark, I'm going to draw this kind of coming down here. This is our axis, kind of like. Okay, let's look at this part. Our center line is going to be at -1. They usually use a dashed line to show that. So this is our center line. Let's put CL. And from the center line, we're going to go up 2 units. That would be at 1. And down 2 units. So that would be -3. Huh? And I like to dot those in also. So we know our graph is going to go into this space right in here. Okay. And this is kind of our main line right here. Maybe we can do it with a. Sometimes this is 0 right here. And let's darken this out. Maybe you can see it better. You could do that. You could use a different color or something. Okay, so let's put in our divisions and let's just do fourths. It'll be easier. Okay, this is fourths. So this would be 1, 2, 3, 4, 1, 2, 3, 4. Right here, this is pi over 4. This is negative pi over 4. Right in between these two is going to be 0, right? Okay, so now what's the name of this point right here? If this is 2 pi over 4, 8, half of that would be -1 pi over 8. So that's negative pi over 8. This is pi over 8. 0, 1, 2, 4, 2 eighths, 0, 1 eighth, 2 eighths. Okay, so and I got my divisions. Now I'm going to do my graph. Okay, so sine is usually, I'll put it down here. Normally it would be 0, 1, 0, -1, 0. But we're going to double that. Going to use that 2. So this is going to be 0, 2, 0, -2, 0. So I'm going to start at 0, not here, but on my center line. I'm going to go up 2 units. Going to go down 0. Going to go down to -2 on this line right here. That's why it's easier to draw that line. And then back up to 0 on the center line. So it's going to look like this. That wasn't so bad. And there's my graph. Negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. Even if you're having a little trouble with these 2 points, at least get these points correct. The beginning point, the middle point, and the ending point, and just realize that there's a point in between those. You know, so if you had a little trouble, and you were trying to graph this, what you could do is just say, okay, I've got pi over 4. I'm going to divide this up into 4 places. And then this is negative pi over 4. I just put it over here. This is 0. This is pi over 4. At least that would help. Even if you can't figure out the name of these, at least you could put, you know, some indication that there was a line there. And then you could go, up, then down, then up, then down, like that. Now, if you want to extend this, just kind of figure that this is going to go like this, and this side is going to go like this, and then you have 2 periods. Anybody? Anyone? Josh? Romero? Have I confused you totally? Do you want to say another one, or is that good? Well, I'll tell you what, I'll be on tomorrow. If you have questions, try some out of the exercises. They're going to be a little difficult, especially 25 to 33. We try the odd problems. You can kind of look in the back of your book and kind of see the solutions. Try those. I wouldn't worry too much about 30, 39. You might try one like 43. That one's kind of difficult. But try a few of those. If they have a number in front, I would say, like, looking at problem number 29. I think it would be easier to handle this problem if you distribute this out and say this is pi x over 2 and distribute it out here. This would be minus pi over 4. I would do that. Then when you want to set up your interval, you're going to go 0 is less than or equal to pi over 2x minus pi over 4, like that. Is less than or equal to 2 pi. Set it up between those two extremes. Then you can get rid of this, add pi over 4. So this would be pi over 4. This would be pi over 2x. This would be what? Now that's a little harder to add, so change this to fourths. 4 fourths plus 1/4 is 5 pi over 4. Now you want to get rid of the pi over 2. So you're going to multiply everything by 2 over pi. You can even jot it down. See, the pi's cancel out. You get 2/4 or 1/2 is less than or equal to, everything cancels out. 1 is less than or equal to, pi's cancel out, you get 10. Over 4, huh? What is 10 over 4 reduced down to 5/2? So this is kind of a weird looking little problem, huh? Did I multiply that out right? Let me check something. A weird little problem here, isn't it? Oh, I see. On this one, they didn't want you to graph it. They just wanted you to do a couple of things on this 29. Okay. They wanted the amplitude. Okay, well, that was easy to do. The amplitude is 3. Okay, they didn't want you to graph it. No wonder. What's the period? The period would be, well, the period would be, see, that's your number right here. It's 2 pi divided by pi over 2. So the period would be, if you multiply this out, this would be 2 pi times 2 over pi. So the period should be 4, huh? Let's see if that's correct. The period of this function should be 4. Maybe I made a mistake here someplace. All right, let's take a look and see. 29, yeah, the period is 4. It says any phase shift. Well, you do have a phase shift on here. This is your phase shift. And your phase shift, I believe, let's see, 29 would be this number right here before we multiplied it out. That's your phase shift right there. Phase shift is, but it's always the opposite. Just take this and set it equal to 0. And your phase shift will be x equals 1/2. That's your phase shift right there, 1/2. Take this expression in the parentheses, set it equal to 0, and you get your phase shift. What else do they want like this? Any vertical translation, did it go up or down? Was there a number here, in other words? Was there a change in the center line? 29, there was none, so that's it. No vertical. In other words, did the center line change? They were asking for the center line. None. So they don't really want you to graph this thing because this would be pretty confusing to graph. They just want you to do this. Okay, sorry about that. All right, that's it. Adios.